This video will discuss question 32. The clocked SR latch, drawn in figure 6, uses transistors Q1 and Q3 designed with the minimum size W over L is 1. What should be the widths of the transistors Q1 and Q2 so that the metastable point of the latch Q1, Q2, Q3 and Q4 can be set at 54% of VDD? And then 8 options are given for combinations of W1 and W2. Let's start with computing W1. In the question it has been given that the aspect ratio of transistor 1 is 1. And since Q1 is an NMOS transistor in a latch that has been characterized by this CMOS inverter, that means that the channel length of that transistor has to be 40 nanometers. The width of transistor 1 has to be 1 times the length of transistor 1, and that is 40 nanometers. Finding W2 is a little bit more complex because that requires us to have a close look at the switching voltage. The question requires us to have a switching voltage at 54% of VDD. Since VDD is 1 volt, that means that the switching voltage has to be 0.54 volts. The switching voltage can be computed using a formula from the formula sheet, which goes as follows. The only parameter in this equation that is not known is the parameter R, because R depends on the aspect ratios of the transistors in the circuit. We can now use the numerical values from figure 5 to simplify this equation somewhat. And if we now solve this equation for R, you will get that R is 1.5. R is equal to the square root of the ratio of mobilities and the aspect ratios. We know mu p and mu n through this mu p Cox and mu n Cox from figure 5. That ratio is 50 over 150 or 1 over 3. The PMOS transistor in our latch is Q2 and we would like to know the width of Q2. That means that W2 is the unknown here. But we do know the channel length. The channel length of that transistor is 40 nanometers. We now still have to fill in the aspect ratio for the NMOS transistor, but the NMOS transistor in our case is Q1 and that has been given to us in the question as 1. That will yield us the square root of W2 over 120, and we know that that has to be equal to 1.5. And if we now solve that equation for W2, you will get that W2 has to be 270 nanometers.